Welcome to the video for the mat050 final study guide for the final. So this is page 2. I'll be starting with question 3. I'm assuming you've looked at it. So I'll go ahead and show you how I would approach this problem. It says if you needed to estimate the value of square root of 26 without using a calculator, which whole number would you say it is closest to? I'm going to start with the perfect squares. So I'm going to take 1 squared, which is 1 times 1, which is 1. And then I'm going to do 2 times 2, 2 squared. 2 times 2 is 4. 3 squared means 3 times 3, that's 9. 4 squared is 4 times 4, or 16. 5 squared is 5 times 5, or 25. And 6 squared is 6 times 6, which is 36. And I can already see 26 is between 25 and 36. So I know that the square root of 26 is between 5 and 6. So I can say the square root of 26 is closest to 5. 26 is a little bit more than 25. Square root of 26 is a little bit more than the square root of 25, or a little bit more than 5. Take a quick look at question 4. Pause the video when you've looked at question 4. Come back and see if your solution agrees with mine. Okay, question number 4. Angelo wants to buy a car that costs $13,000. He can afford to pay up to $200 per month and wants to pay it off in 5 years. Assuming no interest payments, this is not an interest problem, and no changes to his payment schedule, how long will it take him to pay it off? Will this fit his desire to pay it off in 5 years? So I'm going to say X is the number of months. So number of months that he's going to pay it. So every month he's going to pay 200. First month he pays 200. Second month he pays 200. The third month he has paid 200 3 times. The fourth month he has paid 200 4 times. So he's going to pay 200 X times, where X is the number of months. And that's going to equal 13,000. And now I've got an equation. We've solved equations. What we did in this case, where we have 200x, we divide both sides by 200. X is the number you multiply by 200 to get 13,000. So these cancel. We divide by 200 to see what X is. And actually, I'm going to reduce the fraction to 130 over 2, which is 65. So X is 65 months. I'm going to take that 65 now and divide it by 12 to see how many years, because there's 65 months. I'm going to multiply that by 12 months. I'm sorry. I'm going to multiply it by 1 over 12 months, or 1 year. Per 12 months. The months are going to cancel, and I get 5 and 5/12, which is about 5.4 years. Some people came at this from a different direction. They said he's going to pay it off in 5 years. X is the amount of money that he has to pay every month. So they said 5 years times 12 months per year times X equals 13,000. And then they solve for X there. So 5 years is 60 months. They divided both sides by 60. They had X equals 1,300 divided by 60. Which is 206 into 100. About 17. So that they would have to pay, or Angela would have to pay $217 every month. Okay. Pause the video now, take a look at question number 5. That's one of the important ones for the final. And when you come back, you can see what I would do on that test, on that question. Okay, now that you've looked at question 5, you have to put a smiley face by the letter if the terms are like or can be made to be like. So put an X if they cannot. X and Y are not the same necessarily. They can be the same, but we have no way of knowing that they're going to be the same. So we have to treat them like they're differently. We cannot add those terms together. We might have an expression, that's an expression, but that tells us to add two different things. We can't add them up, and we can't add the 5 and the 7 because they're multiplied by different things. Question B, I have y to the 4th and y to the 8th. Those are actually different. I cannot add the y to the 4th and the y to the 8th. I can add y to the 4th and y to the 4th, but I cannot add y to the 8th. Question C, I have 5x plus 7x. Those are like terms. We can say that's 12x. So I'm going to put a smiley face there. My pen doesn't draw dots very well. Question D, 5/8 and 7/8. We can add 8s. We would get 12/8. They're the same denominator. We can add them. So I draw a smiley face. 3/4 and 5/8. They're not like, but we can make them like. I can change the 3/4, multiply the numerator and the denominator by 2. I get 6/8 plus 5/8, and that would be 11/8. So I can do those, combine those. So I put a smiley face. 5 miles and 600 feet. We can change feet to miles. We can change miles to feet. I could multiply 5,000 times, I could multiply 5 times 5,280 and then add 600. So they can be made to be like. They're not like terms, but we can find a way to make them the same. So that gets a smiley face as well. Miles and grams, we cannot change miles to grams. We cannot change grams to miles. They are measurements of different things. There's no reason to add those two together. And D I didn't change, so don't worry about that. That would be a smiley face, though. Anyway, pause the video now, take a look at question 6, then come back and I will show you how I would do question 6. Okay, now that you have looked at question 6, it's talking about a survey. Survey was completed that asked students to report how they did in their last math class. There were 100 students surveyed, 49 reported getting an A, 25 reported getting a B, 11 had reported getting a C, 5 reported getting a D, and 10 reported getting an F. If we add those numbers together, 49 plus 11 gives us 60. Uh, 60 plus 25 gives us 85. And 85 plus 5 gives us 90. And then 90 plus 10 gives us 100. So I know that everybody has reported their grade. Every one of those 100 students has reported their grade, and nobody gets counted twice. Everybody is only included in one category. So this is a good candidate for a pie chart. So I'm going to say a pie chart. And my reason is that the numbers add up to the total. Nobody is counted twice. There's no overlap between the categories. You either get an A, or you get a B, or you get a C, or a D, or an F. Everybody has to get a grade, and nobody can get two different grades. Take a look at question 7 now. Think about that. Would you use a pie chart or a bar graph there? Pause the video then, and I will explain how I would answer that question. Okay, now that you're back, now that you've thought about question 7, in this one it says a survey was completed that asked students to report their favorite winter activity. There were 30 people surveyed. Their results were 12 like skiing, 13 people like snowboarding, 10 people like sledding, and 7 people like snowshoeing. And the clue here is that in the context, it is possible for a person to like skiing and snowboarding. So there could be a person who is counted in the 12 and in the 13. That person could also like sledding and snowshoeing. So it's possible for a person to be counted in all 4 categories. And if we add up the numbers, 13 plus 7, you might think about why I added those first. 13 plus 7 gives us 20. And then I have 12 and 10. 12 plus 10 equals 22. When I add those together, I get 42. And we were told that there were only 30 people. So some people had to like more than one thing. As a result, the numbers don't add up to 100, and I'm not going to add up to 100%. With a pie chart, I need to have 100%. And I need to have everybody in only one slice of the pie. So I cannot use a pie chart here. I have to use a bar graph for that reason. And when you do this, you should write out your reasoning. I explained it because the pen doesn't work very well. Thank you. Go ahead and go on to page number 3 now.